All right, class, we are ready for chapter 2 now. And because of all of the work that we've done in chapter 1 with solving equations, it really is going to make chapter 2 seem so easy. There are just a few little things that we need to talk about. And in the first section, 2.1, we're going to be talking about writing and graphing inequalities. So we are switching from dealing in equations, which equations we know have equal signs, to now we're going to be dealing in inequalities. And we have 4 inequality signs that we know. So I'm going to go ahead and write them on here. And so we have the less than sign, less than or equal to, greater than or equal to, and then just the greater than sign. Now, I don't know about you and what you guys have done with inequalities, but I remember when I was in school learning these, I had a really hard time keeping straight which one was the less than and which one was the greater than. And so I knew, because in grade school, they teach us all the way now, even in kindergarten, that you remember these kinds of problems that would have a number and then they'd put a little circle in the middle and then a different number. And you had to figure out which inequality sign went in the circle. So when we were learning this, we would say, okay, pretend that the equal sign or the inequality sign is the mouth of an alligator. And so we would say, nom, 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 there's my alligator mouth. And it always wants to eat the one that's bigger. Okay, so that's all well and good. I know that I always point the mouth of my inequality towards the bigger number. But then I would need to know, well, how do I read this? Like, how do I read this symbol? Which one is it? Is it the less than or is it the greater than? And when I was in school, I just always had to look. I had to reference my notes and my picture. But I finally got to where I started having some sense of what was happening with my numbers. I mean, if I was going to read the numbers 1 is blank than 4, would I fill in, is 1 less than 4 or is 1 greater than 4? Well, it's less than. And so I started thinking of it, of the name, not so much in terms of matching it to the symbol, but more in terms of trying to understand the relationship with the numbers. Okay, so I'm going to be referencing that and drawing us back to that over and over again. In our heads, we can almost think of, okay, well, which one is bigger? Well, the 4 is bigger. The mouth points to the 4. And I read this from left to right. And so I would say 1 is not bigger than 4, so it must be less than. So that's how I think through the problem. So now, in order to make this a little bit more like Algebra 1 level and not so much kindergarten level of just filling in the symbol, we are going to actually start off by talking about how do we take a sentence that's written in words and actually change it into a mathematical sentence that has numbers and symbols in it. And so when we read this, again, I want us just to remember that as we read a sentence, we read from left to right. You guys know that. But what we're also going to do is match our expression or our inequality. We're going to match it left to right as well. So as I read it, that's when I would write it. Okay. So here's how this would look. We would say a number C. And anytime they give us this, that is just telling us that's our variable. So this is where we put in the variable. And they're going to tell us which letter to use. So we're going to say C. C plus 9, okay, well, so C plus 9, we're turning it into symbols, is greater than or equal to. Okay, so thinking about greater than, don't look at your notes. Think greater than. If this C plus 9 is greater, is it going to get the point of my inequality, or is it going to get the alligator mouth of my inequality? It's going to get the mouth. So we're saying that this piece is greater than or equal to. So when we have the or equal to, that's when we're going to include the bar underneath the inequality, and then -6. That's my answer. Let's try this one. 6 is greater than, oh, okay, so this time they've kind of rearranged us. We already have our greater than, and we haven't had our variable yet. That's okay. So 6 is greater than, so that means it's going to get the mouth. There's no equal to this time. So now the right-hand side is a number p minus 8. So this, a number p, this is all going together. This just means use the variable p, and we're going to -8. All right. Well, that's not too bad so far. Again, it's just that as we read it, we write it in symbols. Ooh, but take a look at this one. -7 is at least twice a number k minus 4. We haven't seen this. Is at least. Okay, so let's just get everything else down, and we'll just leave a little circle for this piece again. -7 is at least, we got to figure out which inequality sign goes in here. Twice a number. What does it mean if I'm taking twice a number k? Yeah, we're going to multiply it. Twice a number k minus 4. Okay, so when we're talking about at least and the other one, we might have at most. What are we saying when we're talking about these? Okay, so let's actually again get this into context, at least. If I'm saying I want at least 5 people to stay after class. I want at least 5 people to stay after class. Do I want, if I get 5 people to stay, am I happy? Sure, 5 works. If I want at least 5, yep, 5 is a good number. What about 4? I want at least 5. Does 4 work? No, that doesn't work. How about 3? Nope, we're going the wrong direction, aren't we? So these numbers don't work. If I'm talking about at least, that means 5 needs to be the least that I'm good with. And then I need to go greater than that. Okay. So I need the greater than sign. -7 is at least. So I need greater than or equal to -7. Okay. These are where I get tricky. Let's talk about at most here. That way you have something to reference. At most, I can eat at most 2 pieces of candy. Okay. I can eat at most 2 pieces of candy. Can I have 0 pieces of candy? Sure, because 2 is the most. So is 1 going to work? Yep. And 2 is going to work. Yes, because that's the most that I can have. 3 and 4 and things bigger than that don't work. So when we're looking at most, we're saying 2 is the biggest and we want everything less than that. And that is confusing because it's like it's opposite. I see most and I'm thinking greater, but it's not. We're saying we need to be 2 is the greatest that's going to work and everything else needs to be less than that. Again, when I come up here and I see the word least, it makes me think less than, but that's actually wrong because we're saying 5 is the least that I'm happy with. I want everything bigger than that. So anytime you see at least, you're going to say greater than or equal to. Anytime you see at most, you're going to say less than or equal to. These are really important to make sure you have written down somewhere. Oh, but then I gave you another one. Check this one out. It's another way of talking about inequalities that gives us different wording. 10 is no more than the sum of 3 times the number y and 4. Okay, well, let's start from the left. 10 is no more than, okay, well, let's just put a circle. We'll fill in our symbol in a minute. The sum, that tells me I'm going to be adding something. What am I adding? 3 times the number y. Okay, so 3y. And I'm adding 4. Okay. So let's get again on a number line because we got to figure out this whole is no more than piece. If I'm on a number line, I'm talking about the number 10, 11, 12. Let's go the other way too and get 9 and 8. 10 is no more than. It's not more than. If it's not more than, then it means it needs to be less than. 10 is no more than the sum of 3y and that. So this is going to give us for sure our less than. Does it include the equal to? Yes, it's not more than. It means it can be 10, but it cannot be more than 10. So 10 is included. So we are going to put the equal sign with it. All right, I hope we did okay with that one. We're going to talk through, you guys are going to get to practice doing some of these on your own at, well, we'll see how we do. I know you guys are watching the video now, and then our next class time is when we're going to practice this. Okay, so let's move on. Because we have solutions to inequalities that include more than one number, we got to figure out how to graph these. So graphing solutions is the next portion. Okay, so a couple of things to remember. Let's just talk about our vocab words again. When I'm talking about a solution again is any number that when I plug it into the original equation or inequality, I would normally only say equation, but now we have to throw the word inequality in there. Okay, so any number that when I plug it into the original inequality, I get a true statement. So the thing to remember is that, again, solutions always give us a true statement. When we were looking at true statements before, we were seeing things that were like 9 equals 9. That's a true statement. And this would give us an infinite solutions type of answer. Or we might see 10 equals 0. And then this one was a no solutions because this wasn't a true statement. But now our statements are going to include inequality. So let's take a look at that. If I give you an example like this and I say x is greater than or equal to 2, I want us to take a look on a number line. And we're going to be using number lines a lot because this is how we graph solutions. Okay. If I'm talking about x equals -1, if I plug -1 into this inequality, is -1 greater than or equal to 2? Well, no, it's not. That is not a solution because that's not true. Actually, we would usually just draw a little dash through the line like that. Okay, well, let's try 0. Is 0 greater than or equal to 2? No, of course not. Okay, so this is not a solution on my number line. This is not a solution. Where's my solution going to start? The number 2 right here. But when we're talking about graphing inequalities or graphing solutions, we have two things that we can use. We can use an open circle on our number line, or we can use a closed circle on our number line. And it's important to know what this means. If I have a closed circle, that means that that number that I'm putting that open or closed circle on is included in the solutions. That's what that closed circle means. The open circle means not included. We'll talk about an example of that one in just a second. Okay. Now, is 2 greater than or equal to 2? Yes, it is. Because the equal sign is there, we get to include 2 in my solutions. Okay, well, how about 3? Is 3 greater than or equal to 2? Yep, it sure is. 4 and every number bigger than this. But see, if I leave my answers just like this, what do I do with, say, the number 2.5? Is 2.5 greater than or equal to 2? Yep, it sure is. So that needs to be included. How about 3.5? Yeah. How about 3.1? Ooh, yeah. All of a sudden, what's going to happen is that all of these numbers, every single crazy decimal that I can write down greater than 2 is going to be included in my solutions. So if I'm going to make a graph of all the solutions, we use this shading. So not only does my graph include an open or closed circle, but it also has to include some shading. And so with your shading, I've seen different things. I've seen some people like to draw kind of like this, so to show that we're going to go this direction. I've seen this with more of a curve, and I've seen this with a little squiggle line. All of this is good. I have no problem with any of these different ways of shading. What I am picky about, though, is the arrow. I'm looking for an arrow because if I don't see the arrow, then that tells me that wherever my line stopped, that's where my solutions stop. The arrow tells me that the solutions go on forever and ever. And so I am picky about that being in your solutions. Okay. Let's talk about this one. What if I give you x is less than or equal to 23? Where are my solutions going to be? Well, I always start on the number. Whatever number is given, I always start on this number. And then I need to say, okay, well, is the number included in the solutions? And I look right there. Whether there's the equal to sign or not, that's what tells me. It's a very simple look. So if I have the equal sign, I will have a closed circle. If the inequality does not have the equal sign, then I will use the open circle. So here, 23 is included in my solution. So because of the equal sign, we're going to put a closed circle. Now, which symbol is this one? Is it less than or is it greater than? Well, before you look, I want you to think about this. The mouth is what tells me. The mouth is pointing to the bigger number. So, is x the bigger number? No, it's getting the point of the inequality. So 23 is bigger. And since we read this from left to right, we would say x is less than 23. Oh, I should have said equal to. Is less than or equal to 23. So less than tells me that I need to have numbers less than 23. Well, do less than numbers go this direction? Nope, they go this direction. So we need to include our shading going to the left. Oh, L for less than or equal to, oops, I did, wow. Less than. And then this is also left. That's handy. So we're going to go left. This is how I would graph it. Because all of these numbers anywhere over here are going to plug into X and give me a true statement. How am I doing on my time? Okay, we're getting there. Okay, now the other one that we need to talk about then is what about the ones that have the not equal sign on it? Let's talk about this one. So when I would read this, I'm going to read this. First of all, I was saying X is, okay, what's my symbol? So look at the symbol, find the mouth. The mouth is going to point to the one that's bigger. So X is the bigger one. So X is greater than. There's no dash underneath to be the equal to. So it doesn't have the equal to. X is greater than 1. Okay, here's where I get lots of mistakes. This is really the last thing. Well, there's one more little piece, but that one's super easy. This is the last main thing that I want to talk to you about in this video. Okay, so if I'm dealing with -1, 0, 1, and 2, if I'm talking about this one and I want numbers of X that are greater than 1, okay, well, we know that 2 is a number greater than 1. That one's pretty simple. But what about the number here for, say, 1.5? Is 1.5 greater than 1? Yep, so that would need to be in my solution. What about 1.1? Is 1.1 greater than 1? It sure is. What makes these challenging to graph is that I want every single number right up until I get to the number 1. So I want 1.0001 to be included in my solutions and then therefore included in my graph. But I cannot have the number 1 because 1 is not greater than 1. 1 is equal to 1. So we use this open circle to show that we want everything right up until the whole number. And then we're going to move to the right. We're going to shade to the right. So the mistake that most people make on these is that if they see something like X is greater than 3, usually they'll say, okay, well, 3, 4, 5. And then they start like this and shade to the right. Or sometimes I see the open circle here and shade to the right. When we're looking at our graphs, the number that we see in the inequality, that is the number that we're going to put the dot on our number line. We just have to decide, is this number 3 going to have the open circle or closed circle? So we don't have to worry about shifting up or down, okay? And then greater than would go that way. Okay. One more little tip is that when we look at our inequality sign, if I put a little line through here, my symbol is going to tell me which direction to shade. Now, that only works as long as the variable is written first. Okay, so what this means, what I mean by that, the variable is written first. If I were to write an example and say, how about this one? Okay. How would I read this? 7 is it greater than? Nope, it doesn't have the mouth, so it's less than. 7 is less than X. In this case, because from left to right, the number 7 is written first and not the variable. Sometimes the mistake that I will get is that people will look at the inequality symbol and they'll say, oh, I need to give it an open circle because it doesn't have the equals. And then I'm going to shade that way, make this arrow tell me which way to go. But If I read this and I graph it, from the graph is always actually telling me the variable first. If I were to rearrange this inequality so that the x is written first, notice how the x is getting the mouth. Therefore, the x needs to get the mouth over here. And now when I read it this way with the variable written first, x is greater than 7. So greater than points to the right. So if you're going to use the arrow trick by looking at the inequality symbol to tell you which direction to shade, you have to have the variable written first, okay? The variable has to be written first. Now, the final thing, honestly, guys, this is like my favorite because this last piece is really setting us up for what we're going to do in the next like 3 sections that are so easy. You guys are going to do amazing on it. You are going to check to see if a number is a solution. So, for example, if I give you this inequality, c plus 4 is less than -1. We're not solving, we're not graphing anything right now. What I'm wanting you to do is to check and see if 5 is a solution. Well, what happens with solutions again? We get a true statement. When do we get a true statement? When I plug a number back into the original. Okay, so I'm going to say, well, is 5 plus 4 less than -1? What is 5 plus 4? 9. Is that less than -1? No, it's not. So 5 is not a solution. We're just taking the number that they're asking us to check, we plug it into the original, and sometimes in textbooks, they'll even put like a little question mark above the inequality like that to show that we're checking. We're not sure. And then we get our answer no. Let's try another one. Let's do this one. Let's say 10 is less than or equal to 3 minus m. Okay, and I want you to check 7. So we're going to take the 7 and we're going to plug it in for the m. 10 less than or equal to 3 minus 7. Now, we're not adding 7 to the other side. We are doing nothing in terms of what we were doing in the previous chapter for solving. Here, we're just checking. We're just checking to see if this gives us a true statement or not. So we're going to simplify this side of the inequality. 3 minus 7 is -4. Is 10 less than or equal to -4? Nope. My answer is no again. Okay, well, what would a true statement look like? Well, let's keep using the same expression, 10 less than or equal to 3 minus m. Let's use that inequality, but this time, let's check to see if -11 is going to work. So we're going to plug -11 in for my m. Okay, here's where I see lots of mistakes. So let's talk about substitution. What we are doing when we plug a number into an equation or into an inequality, we are doing substitution. Now, when we do substitution, I'm going to run out of room. Let me try this again. There we go. Substitution, super important word. Substitution, whenever we are doing substitution, I absolutely require that you put parentheses around the number as you plug it in, especially if there is a negative sign. Okay, I wasn't doing it up here. I should have done it right up here just to start to do the habit, but I knew it would be fine. But here it's super important because we're saying 10 is less than or equal to 3, and then I have a minus sign here from my equation. So I need a minus sign from my equation to go here, but the number that I'm plugging in for m is a negative number as well. Well, we are smart, intelligent people, and what do we know about a negative negative? What happens to it? It becomes a positive. Very good. So anytime I see a negative negative, I cross them like this. I've seen some people extend through and make it a big plus like that. I don't have a preference necessarily, whatever you're comfortable with doing, as long as you don't make mistakes. So we're going to plug it in. And so now we're going to say 10 is less than or equal to 3 plus 11 is 14. Is 10 less than or equal to 14? Yes. That is the end of our video, and we will be doing practice of these in class. I may even be giving you an assignment today in class because I know that you're watching this video in class today. So we'll see how that goes. We'll talk to you guys soon.